Hello everyone! Welcome back to our channel, where we explore the fascinating and sometimes unsettling realities of the world around us. When you think of California, you probably picture endless sunshine, iconic beaches, towering redwoods, and the glitz of Hollywood. It's a place of dreams, innovation, and natural beauty. But there's something most people forget. Beneath all that beauty and excitement, the ground is always moving, sometimes so subtly you'd never notice, and sometimes with a force that can change everything in seconds. California sits right on the boundary of two enormous tectonic plates, the Pacific Plate and the North American Plate. This unique position is what makes the state so geologically interesting and also so vulnerable. These plates are in constant motion, grinding and sliding past each other. Over millions of years, this movement has shaped California's dramatic landscapes, from its mountains to its valleys, but it also creates a dynamic, sometimes dangerous environment. This process is called plate tectonics, and it's the driving force behind California's frequent earthquakes and ever-changing terrain. The plates don't glide smoothly. Their jagged edges catch and lock together, causing stress to build up over years, decades, or even centuries. When the rocks finally break free, all that pent-up energy is released in a sudden jolt, what we feel as an earthquake. These events can be minor tremors or major disasters. This isn't just a story from a science textbook or a Hollywood movie. It's the real, everyday reality beneath our feet, affecting millions of people across the state. While the famous San Andreas Fault often grabs the headlines, it's just one of many faults crisscrossing California. Some of these lesser-known faults pose equally serious risks. One of the most concerning is the Hayward Fault, which runs directly through some of the most densely populated and economically vital parts of the Bay Area, including cities like Oakland and Berkeley. Scientists are keeping a close eye on the Hayward Fault because of its history of powerful earthquakes and its potential to cause widespread destruction in the future. Understanding how this fault works is crucial for protecting ourselves, our families, and our communities. Preparation and awareness can make all the difference when the next big quake hits. The Hayward Fault isn't just a line on a map, it's a real, present danger that affects the lives of millions of Californians every single day. So, why should you care about all this? Because the risks are real, and they impact everyone living, working, or visiting California. This process is happening right now, beneath our feet, and being informed is the first step to being prepared. Knowledge is power when it comes to earthquake safety. So, let's dive deeper into what makes the Hayward Fault so important and so dangerous. Stay tuned as we uncover the science, the risks, and what you can do to stay safe. Let's get into it. The Hayward Fault is a right lateral strike-slip fault, meaning the two sides of the Earth's crust slide past each other horizontally, rather than moving up and down. This sideways motion is subtle, but over time it can cause dramatic changes to the landscape and the built environment. It's a major branch of the larger San Andreas Fault system, but what makes the Hayward Fault unique is that it runs directly beneath the heart of the East Bay. It slices through densely populated cities like Berkeley, Oakland, Hayward, and Fremont, threading its way through neighborhoods, business districts, and critical infrastructure. This fault isn't hidden away in remote mountains or forests. It cuts right through the places where people live, work, and gather. Stadiums, hospitals, schools, and thousands of homes are built directly atop or near the fault trace, putting countless lives and properties at risk. What makes the Hayward Fault especially dangerous is its proximity to millions of people. The East Bay is one of the most densely populated regions in California, and the fault's path puts entire communities in harm's way. You can actually see evidence of its slow, relentless movement, known as aseismic creep, in everyday places. Cracked sidewalks, offset curbs, and misaligned fences are all subtle reminders that the ground beneath is constantly shifting, even when we don't feel it. At UC Berkeley's Memorial Stadium, the fault has literally torn the building apart over decades. Engineers have had to reinforce and retrofit the stadium multiple times, as the ground beneath it continues to move in opposite directions. But this slow surface creep isn't enough to relieve the deeper strain building up underground. Scientists monitor the fault closely, using sensitive instruments to track every tiny shift. Below the surface, parts of the fault are locked tight, unable to move. These locked segments are storing up enormous amounts of energy, waiting for the moment when they finally break free in a major earthquake. The Hayward Fault is like a stuck zipper. One violent pull could unleash massive destruction in seconds, ripping through the landscape and everything built upon it. Its urban location, locked segments, and a long history of powerful earthquakes make the Hayward Fault a top concern for scientists, engineers, and public safety officials. They know that when, not if, the next big quake strikes, the impact could be catastrophic. It's a geological troublemaker hiding in plain sight, woven into the daily lives of millions who may not even realize the risk beneath their feet. And with experts warning that the Hayward Fault is overdue for a major event, the question isn't whether it will happen, but when. Scientists are sounding the alarm about the Hayward Fault for a reason. By studying soil layers and earthquake history, they've found that major quakes hit this fault about every 150 years. The last big one was in 1868, over 150 years ago. That means the fault is overdue, and the risk is rising. The USGS estimates there's a 1 in 3 chance of a magnitude 6.7 or greater quake here in the coming decades. With millions living nearby, the stakes couldn't be higher. It's not a question of if, but when. This isn't about fear, it's about being ready. When science says, pay attention, it's time to prepare. How does an earthquake actually happen on the Hayward Fault? To answer that, we need to look deep beneath our feet, where immense forces are always at work, shaping the very ground we live on. The Pacific and North American plates are locked together by friction, like two pieces of sandpaper pressed tightly. For years, even decades, these plates try to slide past each other, but the rough edges keep them stuck, unable to move freely. As the plates keep moving, stress builds up in the brittle rocks near the surface. The ground above may seem calm, but deep below, tension is mounting, quietly storing energy that will one day be released. Eventually, the strain overcomes the friction, and the fault snaps. This sudden break is like a stretched rubber band finally letting go, unleashing all the pent-up energy in an instant. The rupture starts deep underground at a point called the hypocenter, then races along the fault at thousands of miles per hour. The energy travels outward, breaking rocks and shifting the earth as it goes. This sudden movement releases seismic waves, what we feel as an earthquake. These waves ripple out in all directions, shaking everything in their path. P waves arrive first, a sharp jolt. They move quickly, often catching people off guard with a sudden, startling motion. S waves follow, causing the most shaking and damage. These waves move more slowly but pack a powerful punch, making buildings sway and objects tumble. Surface waves roll along the ground, making the earth feel like it's rippling beneath your feet, as if the solid ground has suddenly turned to liquid. All this energy, stored for decades, is unleashed in seconds. The transformation is violent and swift, changing landscapes and lives in the blink of an eye. That's why earthquakes are so powerful, and so dangerous. The destruction they cause can be overwhelming, leaving cities and communities struggling to recover. The Hayward Fault is primed for this kind of violent release. It runs directly beneath densely populated areas, making its potential impact even more concerning. Understanding the physics helps us grasp the urgency. By studying how and why these quakes happen, scientists hope to better predict and prepare for the next big event. The next rupture could happen at any time. The clock is always ticking, and the more we know, the better we can protect ourselves and our communities. Imagine a magnitude 7.0 earthquake striking the Hayward Fault. The shaking would be violent, impossible to stand, deafening noise, buildings and infrastructure breaking apart. Older buildings and soft-story apartments would be at high risk of collapse. Roads, bridges, and overpasses could fail, cutting off transportation. Gas and power lines would rupture, sparking fires across the region. Water mains would break, making firefighting nearly impossible. Emergency services would be overwhelmed. Hospitals could be damaged or forced to evacuate. For days or weeks, there could be no water, power, or internet. The economic losses would be staggering, and recovery could take years. Hundreds of thousands could be displaced, creating a housing crisis. This wouldn't just be a local disaster, it would have national and global impacts. Understanding this scenario isn't about fear, it's about motivating action. To see the future, look to the past. On October 21, 1868, the Hayward Fault ruptured with a magnitude 6.8 quake. The Bay Area was sparsely populated, but the destruction was severe. Buildings in Hayward and San Leandro were nearly wiped out. Even in San Francisco, miles away, unstable soils amplified the shaking and caused major damage. The quake opened a 20-mile fissure and taught us that soil type matters as much as building strength. About 30 people died, but the population was only 260,000. Today, over 7 million people live in the region with 2 million right on the fault. The 1868 Quake is a blueprint for what could happen again. It's a stark reminder of the Hayward Fault's power. History shows us why we must be prepared. We can't stop earthquakes, but we can build smarter. Modern buildings in California are designed to bend and flex, not collapse. Retrofitting older structures, bolting homes to foundations, reinforcing bricks, strengthening bridges, saves lives. Billions have been invested in making Bay Area infrastructure safer, including the Golden Gate and Bay Bridges. Base isolation technology, giant shock absorbers under buildings, protects critical facilities like hospitals. Engineering alone isn't enough. City planners use zoning laws to keep new construction away from the most hazardous areas. Public education and disaster drills like the Great Shakeout help everyone know what to do. By combining smart engineering, planning, and preparedness, we can reduce risk. We can't eliminate earthquakes, but we can survive and recover. Every upgrade is an investment in safety. The goal, a community built to withstand the shake. Resilience is possible, if we act now. Personal preparedness is just as important as engineering. Know what to do. Drop, cover, and hold on during shaking. Most injuries come from falling objects, not collapsing buildings. Make a family plan: where to meet, who to call, what to do if separated. Build an emergency kit: water, food, first aid, flashlight, radio, and a whistle. Secure heavy furniture and appliances. Strap your water heater to the wall. Learn how to shut off your gas and water. Take a first aid class and participate in community drills. Preparation turns fear into action. Every step you take makes your home and community safer. You don't need to be an expert, just be ready. Science gives us the tools, it's up to us to use them. Preparedness is power. The Hayward Fault is a real and urgent threat, but knowledge is our superpower. We know where the fault is, how it works, and what it can do. Science lets us build stronger, plan smarter, and prepare better. The future isn't set in stone, it's shaped by our choices today. Engineers, planners, first responders, and everyday people all play a role. Every emergency plan, every retrofit, every community drill makes us stronger. We're all part of the solution. Let's listen to the science, take action, and build a safer future together. An earthquake will test our buildings and our spirit. By working together, we can survive, recover, and thrive. The power to be ready is in your hands. Let's use it. Thank you for being part of a safer, more resilient community.